This video contains disassembly, reassembly, technical evaluation, durability and toughness test of CJRB 1915-BU. I'm a mechanical engineer by trade and formerly a CNC machinist. So I will give you my technical insights as I disassemble and reassemble this knife. Folding knife is a system that you carry in the pocket every day. And as a system, it's as good as the sum of its components and as bad as its weakest component. So let's find out what makes this system go click. I'm very excited about the fact that every fastener, every screw in this knife had a generous application of Loctite. In one case it was a little overly generous and it got into the liner. But that's not a big deal. It's better to have more than necessary than none at all, because Murphy's Law of Engineering states whatever can come loose will come loose. Please use a really good quality Torx bit. It's T6 for the small screws and T8 for the pivot screw. If you don't use quality tools, you will strip those T6 screws very easily, and they're not easy to replace. What also rubbed me the right way was the fact that the pivot hardware has a locating feature, and that means you can unscrew the pivot screw from one side. You don't need to back it up with another T8 bit from the other side. These brass colored accent pieces, accent washers, they're actual solid brass, which I'm also very happy about, because in some other knives it's a anodized aluminum or steel. And the scale came off with no trouble at all. And here I took a minute to examine the system. It's the first time I see this type of knife. And I'm looking at the Omega springs. I detect there's some lubricant, lightweight oil of some sort on all the parts. I wipe it off. I don't recommend having a lot of oil in your pocket knife, because anything that's in your pocket will end up stuck to that oil. And it's a very interesting version of the access lock or crossbar lock. You're about to hear some piece of mechanism dropping. There are 4 tiny pins that used to direct the slider that then moves the crossbar, and they pass through the slider and into the slots on the liners. Be very careful, they're not captive in any way, and tiny, so you can easily lose them. And here's a little bit of a funny moment. As I move to remove the pivot, my first instinct is to unscrew it because it has a T8 socket, but it's not necessary. It's not captive at that point. It's just a decorative feature. I don't know why it's there. I think that's a missed opportunity. Their logo would look good on this piece of hardware and probably cost them as much as putting a socket. And as I was contemplating this thought, this is what happened. And that was the bottom bearing, which just simply fell out when I was pulling the blade out. If you, my discriminating viewer, are concerned about this white plastic looking material that the bearing is made out of, let me put your mind at ease. This stuff is called machinable plastic, but actual name is phenolic thermoset. And it's very stable in high temperature and aggressive chemical environments. To paraphrase Benjamin Franklin, it won't corrode, it won't swell, and you'll be grateful as hell. Sorry, but I figured if you got that far into the video, you will appreciate a little bit of humor. Well, at any rate, the main load-bearing component in those bearings are the ceramic bowls, of which there are 8 per bearing, or 16 total, that carrying all the loads that you exert on your blade. And we're back to the excitement of the screw removal. This segment here should be a purgatory for anyone who likes to put way too much Loctite on their hardware. Clearly there is no shortage of Loctite at the CJRB factory, because somebody went overzealous to the extent that it was very hard to remove that last screw, and the scale was slightly glued to the liner. So for this big she. Keep in mind that little pin will try to come out on that side as well. But the cool thing about the mechanism is this. Look at that. It pivots out of the way and releases the crossbar itself. pretty cool. And then you can lock the crossbar by swiveling it back. So in my assessment, the slider, the 4 pins and 2 slots in each liner had a serious level of complexity. And normally increasing complexity also reduces reliability. The KISS principle, or keep it simple, stupid, was not observed here. Did they hire German engineers? I think the designers were pursuing some ergonomic goals, but I'll get into it later. All in all, it's a very clever interpretation of the axis lock. Dankeschön, mein Herren. The sliding piece is made out of cast aluminum, by the way. This is a weight reduction and manufacturability improvement, which translates into lower cost. But if it was me, I would use some kind of lightweight steel alloy, like magnesium-based alloy, and reduce the risk of wear and tear in all these 6 or 7 mechanical interfaces. Well, since Artisan Cutlery owns this company, maybe they'll implement it into a more expensive model. And here you see it's another iteration of Omega spring attachment. So I'm not gonna stop and talk about it too much here. Let's just say the springs are pretty robust, and the way they attach to the crossbar is exactly the same as you would see on any other crossbar knife. And I'm tipping my hat to the engineers who designed it, because another cost saving here is the liners are identical. They're interchangeable from left to right. As I mentioned earlier, the spacer is glued to the liner with a Loctite. I'm just gonna leave it alone. And the stop pin that prevents the blade from over-rotating is either epoxied or pressed into the liner. I don't know why, but it might be a good thing. Definitely looks a lot like an epoxy. Epoxying steel components together, it's cheating, guys. And it leaves a mess, like you see here. I'm not sure if it's Loctite or the epoxy, though. Ladies and gentlemen, this is model 1915 in all its disassembled glory. Their assembly is so straightforward, I speeded up the video. The installation of the crossbar slider is the only piece that is a little different from any other knife. You just have to remember to move the crossbar into the relief slot, and then when you put the slider on, first you need to put in the front pins that allow the slider to pivot. This is what I'm doing here. It's a little tricky because they're tiny, and you have to install both of them, one on each side of the knife. See here, I realized, no, I need to move the spring back in the position so that I can pivot the slider over the crossbar. And now I can release the little pin on the back side because the spring tension is holding it in place. I'm gonna pop in the pivot pin temporarily to line everything up. I thoroughly wiped the residue of the old Loctite off of the hardware, and then I'm going to apply fresh Loctite to all the screws. Can you see a couple little magnets that I put to the side of my T6 bit? While the bit holder is supposed to be magnetic, the bits are so long that there's just not enough force at the end to hold a screw to them. So these magnets, they save me a lot of headache. To hold the bearings in place while I'm reinstalling the blade, I put a tiny amount of grease into the recesses on the blade. I hate introducing sticky lubricants into the pivot, but in this case it's a necessary evil. And I'll wash it down with alcohol later. I meant to say wash it out. It was a Freudian slip. Once the blade is lined up, reinstall the pivot. And now pop the other scale onto the knife, and you can begin reinstalling the screws. I dip each screw into this little puddle of blue Loctite, starting with the pivot screw and finishing with the pocket clip. I like how the screws are completely recessed in the pocket clip. And in conclusion, I'm doing a couple of function tests, and it seems to be functioning just as well as before disassembly. Most flippers I've used have either a liner lock or a frame lock and a detent, and so the action on this knife feels a lot softer, almost sort of sluggish, and it's due to the fact that you have to overcome the pressure from that crossbar. And if you got that far into the video, you might be interested in this hardness test. This is a D2 blade. If you're interested, there is a video on my channel on how to use this set. While not as accurate as a diamond Rockwell hardness tester, this file test will get you in a ballpark of plus or minus 2 points of HRC. And what I get here is right around 60 to 64 HRC. Some manufacturers prefer to anneal D2 blades back down to 57 to 59 HRC range. So that adds a little bit of toughness to D2. Being a high-speed tool steel, D2 it can be hardened into the 70 to 72 range so that it can cut other hard metals. But the harder it gets, the more brittle it becomes. So going harder, you're basically trading edge retention for less toughness. The factory edge looks a little toothy, but cuts pretty well, as you can see here. I will, however, stroke it a little bit, just a little bit, 6-7 strokes on each side. I'm using black compound on my stroke. It's pretty aggressive, but I don't apply too much pressure. Gentle moves, moderate speed should do it. If I seem a little meditative here, it's because I am. This is a highlight of my day, believe it or not. I wish I could convey the feeling. It's extremely sharp now. Well, maybe this will help you rejoice with me. Check this out. I think the only mass-produced knife that I purchased that could do that was Spyderco Yojimbo. It's now time to go walk my doggy in the park, so let's go and put this knife through its paces. I'm going to say the action is okay. It feels like any budget crossbar lock out there, and basically that's what it is. Bottom line for the action is you're going to use it just like you would use any crossbar lock and not much like the flipper. Wearing gloves restricts you to using it only as a crossbar lock and not as a flipper. By the way, you're looking at my sophisticated test lab, those 3 dead trees in a small area. Leather glove on for safety, time to test it for durability. I'm going to stab that dead tree about 20-25 times. This reverse hammer grip with edge up is very comfortable. I have good purchase for my thumb, and which adds a lot of power to the strike. Switching the grip makes it a little less powerful, probably because the handle is a little too long for my medium hand. It did quite well in the durability department. Nothing came loose, everything is still working. This is the toughness test, so let's do some prying. I'll stay quiet for a bit so you can hear. Maybe hard to hear, but I felt it quite well. Let's go ask our heat treat expert what she thinks. What do you think about this, huh? Come and tell me. What do you think? No? I think she just kissed me to make me feel better. Okay, she's back to calculating the wind speed that was required to knock down this branch. So a budget knife can be done right, like this Elite Tactical that has a D2 blade and an appropriate, what I think, blade geometry. It's a lot thicker, the tip, than CJRB is. And for just a few bucks more, you can get these more complex grinds. This particular knife is in the 60 to 70 price range. And because I think there's fundamentally nothing wrong with the overall design of the knife, maybe I should do something like this. Let me know what you think in the comments. I think giving it more of a spear point shape would thicken it in the right place and relieve the stress. I'd like to hear what you all think. Thanks for watching.